Good evening. I'm Sean Ellis, and I'm really happy to be able to talk to you about taking part in your Montessori child's success at maths. Maths, of course, takes us through every day. We are involved with maths on an ongoing basis. From the time we wake up in the morning, wake up to an alarm clock, which we have set to a certain number, and then going into the kitchen, we'll make some coffee or tea and maybe have some sugar and count out the spoons of sugar. So it's very much a matter of everything we do involves maths in one form or another. You go to the bank, how much money do you deposit or withdraw? And so maths is all of that happens in our everyday lives, and it's more, and it's needed. It's more than just numbers. And I'm hoping to show you some of the other aspects that are also important for your child to have a successful experience of mathematics. Once we get past the basics, of course, it goes into abstract mathematics. And that is brought back into everyday life again as it's applied. Montessori maths is wonderful. Dr. Montessori was a mathematician as well as a doctor. And I think if she had not become a doctor, she would probably have studied mathematics for a profession. And her maths materials are truly a delight. In her book, The Absorbent Mind, Dr. Montessori says, articles of mathematical precision do not occur in the child's ordinary environment. Hence, the child's mathematical tendencies may suffer from lack of opportunity, with detriment to his later progress. Therefore, we think of our sensorial materials as a system of materialized abstractions or of basic mathematics. And if you work with her materials, you will really appreciate the precision there is in these materials. They are very precisely made so that the child will be able to really gain the most from them. There's a very logical progression to the materials, and it begins early on in the practical life exercises and progresses through the sensorial area and finally into the academic area. So in the sensorial area, there are exercises such as the pink tower, the broad stairs, the red rods, the cylinder blocks, all of these made with great precision so that the child will begin this understanding of the maths of these objects. And this structured maths program is very suitable for children because these concepts are all taught in a very hands-on, concrete way, where the child can actually manipulate the materials and it becomes very, very understandable and interesting at the same time. There's a lot of features which are very typical of Montessori materials. Firstly, they must be beautifully made so that they please the child aesthetically, as well as fulfilling their didactic aim. So this is the trinomial cube, and we'll talk a bit more about that later, but a beautiful set of wooden blocks which fit together into a perfect cube. Then another factor that's important in Montessori materials is that the concept that you're teaching needs to be isolated. So for example, in this picture, we see a little boy who's working with the pink tower. Now the pink tower is a size grading exercise, and the child needs to grade the blocks from the largest down to the very smallest one. And each one is very precisely made. So each one varies by 1 centimeter from the next one in the series. And it doesn't matter which side you stand a block on, it is so perfectly made that it will stand on any side, and that 1 centimeter will still be quite perfect. The other thing about Montessori math materials is that they are self-correcting. This means that the materials themselves will show the child when they haven't done it correctly. when they haven't got, in this case, it's also a size grading exercise. When they haven't got the sizes graded correctly, they'll be left with one of the cylinders that doesn't fit. So it doesn't require the teacher to look at a worksheet and say, right, wrong, etc. Here, there's no person giving a judgment on the child's work. The child himself will see if they haven't got it correct. And by perseverance, they learn how to get it correct. Sometimes the teacher may have to represent the exercise, but that's okay, so they just see that it is actually possible. Here I can show you a little bit more of this idea of self-correcting. This little girl is working with the red rods. And as you can see, she hasn't got the order quite correct. So when she's finished, she then uses the smallest block to see if it can go all the way down the stairs. And she finds that it can't, because the next block in order is actually longer than the one before it. So she realizes that there's something wrong, and she will take that one out and then move them so that she gets it into the correct place. So again, as I said, it's the materials which correct her, not a person. So she doesn't feel put down by the teacher. She can see for herself. And the knowledge that the children gain from this, each exercise follows in sequence from the one before, and knowledge is built on what is already known. So they begin with the pink tower, where the dimensions are changing in 3 dimensions. And then they go to the broad stairs, where the dimensions only change in 2. And then finally the red rods, where the dimension only changes in 1. So just the length varies with the red rods. And then the number rods are identical to those red rods, except that they have been divided into segments. And the child can then count on the rod and count. The first one is a 1, the next one is 2 segments, so it's a 2, and so on. But if they pick up a 4, they are definitely picking up something which is bigger than a 1. Whereas when we count on our fingers, we say 1, 2, 3, 4. And if we ask the child what is 4, they might show us 4 fingers. Whoopsie, mine don't want to behave themselves, but they might show us 4 fingers, or they might just point to finger number 4 without realizing that 4 needs to be much bigger than 1. The other thing about most of Dr. Montessori's materials, once the child has learnt how to do the exercise, they are left free to discover for themselves other important things about the materials. And this little girl has discovered that the pink tower and the broad stairs can be laid side by side and make longer stairs. And this little girl also, self-discovery, creative way of arranging the blocks, but still, as you can see, doing the size grading. She's still got them going from the fattest down to the thinnest, from the broadest to the narrowest. As I mentioned, this early preparation for maths begins long before the actual maths area. So even if a child is not working in the maths area, they are already beginning to learn maths concepts. In the practical life area, we have many little sets, mostly color-coded, so that each element is related, although different. They're all orange, but as you can see, they're not the same, but they have something in common. And this is the, just for interest, is the grating exercise. Other exercises in the practical life area are things that where they will be sorting. Here they're sorting out corks, and they would find the different ones and make a set of each type of cork. In the practical life area, they also start learning about sequential order. Just as in maths later on, there is an order in which operations must be carried out. But here we have it being sequenced for washing, I think washing a shell in this case. if we want to clean the shell, it's no good rinsing it and then rubbing soap all over it. We need to put the soap on and then rinse it if we want to get it clean. So there is a sequence, just as when you're bathing or brushing your teeth, there's a sequence to it. And this child, again, is finding the sequence in numbers, and it goes from 1 to 10, getting longer and longer. Children also need to learn a lot of vocabulary, and much of this is where parents can come in with helping in everyday occasions, using these words, which are going to become important later when they're doing maths. Larger than, smaller than, greater, lesser, same, different, odd one out, before, after, more or less, whole, half, quarter, third. So all these ideas can be implemented at home to a large extent, as well as it's obviously we're doing it at school, but it will help the child if they do it even more in practical ways at home. So for example, sets. When you're laying the table, we have many sets. So we have a set for each person of a side plate, a big plate, a serviette, a knife, and a fork. We also have the set of the whole table. And it also helps them with learning about one-to-one correspondence. Have we got a plate for each person who's going to be having the meal? So there's quite a lot that we can ask there. You can also ask questions which bring in the negative. So we could say to the child, please give me something which is not a knife. And then they would have quite a big choice. Or we could limit it down to, please give me an eating utensil which is not a knife. And of course, cakes are a lovely way of beginning on that work of fractions, of learning about a whole and a half and a quarter and an eighth when we've cut the cake into 8 pieces. At home also, you can begin with number recognition in a practical way. When you're going visiting and you see the number of the house, or when you see a car registration plate, there are numbers which the child can start recognizing. And as my children were growing up, we spent a lot of time driving in the car, and we would find games to play with those numbers, like calling out numbers in sequence. So the first person would call out as soon as they saw a 1, the next person would have to find a 2, and so on. And we'd see how high we could go in one trip to town. Of course, counting is very important. You can count just about anything. You can count people, you can count how many knives do we need for everybody to have one. We can count how many toys have you got in your cupboard. And this is the type of game which encourages that number recognition, where they are spinning and then finding the number on their little board. Birthday parties are also a wonderful time where the child can count how many candles there are, how old they are now. Of course, there's a lot of fun to be had in reciting number word sequence, and that can be done in so many ways, with songs, with rhymes. I mean, there's little songs like 5 little leaves so bright and gay were dancing about on a tree one day. The wind came blowing through the town, and one little leaf went tumbling down. Then we start again, 4 little leaves, and so on to the end of it. Now we're counting down. I can't, if we get rhymes like 1, 2, buckle my shoe, 3, 4, knock at the door, then we're counting up. So counting up, counting down, both are important skills for the child to learn and can be done in a really fun way. Then if we get on to looking at what happens in the early maths section at a Montessori school, we find that one of the earliest exercises are the number rods, and which I did mention earlier, where the number is a quantity. So 2 is bigger than 1. You can't pick up a 2 if you don't pick up something that's bigger than the 1, because each number is one rod, but with different segments representing how many there are, how many ones there are in that number. And then they go on to the sandpaper numbers, where the number is cut out of sandpaper, and they feel it at the same time as they hear the teacher saying the number. So there's double sensorial input. And I think this is where this works much better than when they just learn these numbers on a screen. Here they need to use their hands, and that gives them a tactile impression, and it really helps them to learn them better and to learn how to write them, not just to recognize them. And we also have exercises where they trace the number with a little stylus in a board that's had the number cut out from it. And once they've got how the numbers look and how they write them, they are then introduced to the number cards, and those symbols of the numbers are then related back to the number rods. So that's what this child is doing, combining the concrete and the abstract. He's got the small table set of number rods and then little cards of the numbers. Once they've got that 1 to 10, there's a lot more work that needs to be done in the maths area on 1 to 10. So they learn a lot of different exercises, all relating just to 1 to 10. This is the spindle box, where they count out little rods or spindles and tie them into a set. So there's a set of 1, a set of 2, a set of 3. And when they finish it, they realize that they have one ribbon left with nothing in it. And so we can introduce the concept of 0. That this set has got no spindle. It is 0. And another exercise in the 1 to 10 is the cards and counters. This has a secondary didactic purpose in that it introduces the concept of odds and evens. So all the odds have a single counter at the bottom of the arrangement of counters, whereas the evens have 2 at the bottom. They have a pair at the bottom. The odds have just a single. And then in our school, we also include some extensions. This is called stone counting, where there's a box of stones and they put out the required number of stones onto the little round disc, which has a number printed on it. And this is a very popular one, where there's a whole big box of mixed little animals and insects, and they sort them into their different kinds and then see how many there are and which row they ought to come onto in the chart. Finally, of course, they go beyond 1 to 10 into the whole decimal system, and they're learning about units and tens and hundreds and thousands. But the important thing to notice is that they are still working with concrete materials. They are still moving units and tens and hundreds and thousands around, and at the same time learning the symbols for those quantities. And this enables the children to do very advanced sums, like adding up 2,567 to 1,432. And they will do that by manipulating these solid blocks and beads, and then putting them all together and then counting them again as a big group and seeing what the answer is. But it is all manipulation with the hands. They also do things like the teen boards, where they're learning what those different numbers actually mean. That 11 means a 10 and a 1. 12 means a 10 and a 2, and so on. And this helps them to really know that that number, that the 1 in all the teens represents a 10, and the 3 is not bigger than the 1. because a 3 is just 3 units, but the 1 is actually a 10. We also have materials for fractions. And this child has already learned how to write down the different fractions. And from that, she went on to doing sums with fractions and could work out that if she took out, for example, the quarter piece, she would be able to put 2/8 pieces into that quarter pieces space. And she went on, actually still at preschool, into doing very simple addition sums with those fractions. We also have materials to help the children learn about time and mass and volume and money, all mathematical concepts that they need for later life. And the maths area also includes geometry. These are the geometric solids where the child feels the shape, and then using the tray, which has some mealie in it, she can see whether the shape will roll or what print it will make in the mealie. So if it has a flat facet face, that will be shown when she presses it into the mealie. So it could be a rectangle, it could be a square, it could be a triangle. And then there are the curved figures, which actually will roll in the mealie and not make an impression like these. In geometry, we also show them a lot of work with what are known as the constructive triangles. Now, the constructive triangles show the child that one triangle, or actually any geometric figure with straight sides, can be made up of lesser triangles. So in this particular one, the equilateral triangle, she can see that it can be made up just of 2 triangles, or it could be made up of 3 or of 4. But they all in the end make a triangle the same size. And then back to that exercise of the trinomial cube. Algebra. Isn't it just amazing that we can represent algebra with a concrete set of blocks? That's exactly what this does. That a plus b plus c cubed is shown here with blocks. So there's a block that will represent a cubed, another will represent b cubed, another will represent c cubed. And then there's all the other ones that fit into that expression, like a squared b, a squared c, and then b squared a, b squared c, and then c squared a, c squared b. And then, of course, there are 6 blocks, which are a, b, c. And the children sort these blocks out and then build the trinomial cube again with them. So the move to the abstract. We all want our children to get onto the abstract, but they need to have a lot of manipulation of the concrete materials first, because the hand is the instrument of the intellect. And that's being shown more and more with modern research, that the child will learn much better if they are able to handle the materials, to work with it with their hands. There's such a thing as muscle memory, and the muscle actually gets impressions from the materials that it's handling, and that goes to the brain and helps the brain to assimilate the information. Once they have done that, then the imagination comes into play, and then they are ready to go on to the abstract. Remember the saying, 20% of what, or 10% of what we hear, we remember. 50% of what we hear and see, we remember. And 90% of what we hear, see, and do, we remember. So doing is the important thing. Now, a more modern book that's come out quite recently is the book The Science Behind the Genius, a book by Angeline Stoll-Lillard. And she's done a lot of research into how children learn. And in this book, she compares traditional and Montessori schools. And this is one of the things she says. There is abundant research showing that movement and cognition are closely intertwined. People represent spaces and objects more accurately, make judgments faster and more accurately, remember information better, and show superior social cognition when their movements are aligned with what they are thinking about or learning. Traditional classrooms are not set up to capitalize on the relationship between movement and cognition. In contrast, Montessori has movement at its very core. You know the children are free to move around in the classroom. They're free to actually work with the materials. So whether it's total movement or whether it's movement of the hands, the child moves a lot in a Montessori class. So if we just recap a little bit on where you can help your child at home, let's just think about it. I said we can use sets. There are more sets. Sets when they're doing the washing, they're helping you with the laundry, sorting out the white washing from the blue washing, maybe counting how many there are in each of those sets and putting it in the machine. There's also one-to-one correspondence. When we buy a pizza, each person gets a slice, one slice each, and gets handed out. Maybe there's enough pizza for each person to get 2 slices, but they will be able to see that one-to-one correspondence. We also at home, of course, can use a lot of maths vocabulary. On the playground, you might talk about curves and straight lines, and there in that jungle gym, I can see some triangles as well. Quite a lot that one can do on vocabulary out and about and at home, of course. If we're at the zoo, we can talk about sizes. We can talk about both being polar bears. They are in that respect the same, but look, they're so different. One is big and one is small. When we go to the grocery shop, again, a very good time for using maths vocabulary. Can you bring me 1 tin of this, or maybe 2 tins, and so on. So they also need to count out and help you with the counting out of the groceries into the trolley. When we're standing in a queue, maybe for an ice cream, we can count the number of people ahead of us. I wonder how long we're going to wait. Look, it's a very long queue, or in this case, it's quite a short queue. It shouldn't take too long. There's only 3 people ahead of us in the queue. And of course, bedtime books, even if they're not a counting book, can be used as a time for counting objects. Let's see how many birds are in this picture, or let's see how many stars there are. Reciting those number word sequence, 1, 2, 3, 4, 5, etc. And then counting the actual objects. So you can count them and see how many there are. There are lots and lots of rhymes that one can use, lots and lots of songs. What about 5 green and speckled frogs sat on a speckled log, eating some most delicious bugs, yum, yum. And the one I gave earlier, 5 little leaves, there are really so many rhymes. Then some more ideas. There's an Stanford University got together a lot of different people to draw up a program called the Development and Research in Early Mathematics Education. And we have a handout which we can give you on that, but otherwise you can go to their website and download it for yourselves. And it has some wonderful ideas of just very simple little ways of incorporating maths into your everyday movements. It's not a matter of sitting down and saying, and now we're going to do some maths. It's just as you're going out and about around town, the sort of way that you can draw out this vocabulary from the children. And there's the one PDF that we can let you have called Math Snacks. And it comes in different sections, like this one is out and about, but then there are some that are at home or on the playground, and just questions that you can ask to facilitate this maths thinking in the child. Then, of course, communal cooking, whether it's cooking with mom and dad in the kitchen, or whether it's like this, maybe at a birthday party where everybody's involved in making the cake. It involves a lot of maths. If we put the right amount of flour, the right number of cups, the right number of milk, if we don't put any baking powder in, we're going to have a problem. But if we put too much baking powder in, we also have a problem. So we need to count it out exactly. So communal cooking can be a wonderful way for introducing maths and the importance of accurate counting. And then games that you can play, like board games, like snakes and ladders. And there are a lot of other ones that are around that you can use, where the child is throwing a dice and then moving a marker, the number of spaces that the dice tells them. Then there are also puzzles. In this particular one, you need to put together the shapes, but at the same time, the triangles must fit together, and it can become quite tricky. I personally love origami. I love the way that you start off with a square, and when you fold it from one corner to another, you get triangles. And you can fold down the corners of the triangles and eventually get a lovely little puppy dog face. Another one of my favorites are tangrams, although I don't like this colored tangram. I prefer the old traditional one, which came from China, and they were black, all black shapes. Because from the square, you can build a number of different shapes, like this boat, but also many others. And you can challenge each other with making different shapes. So that's all I have to say about how you can help your child with maths. And just remember, at all times, you need to make it fun. Fun all the time, and show that it just is part of everyday life. Thank you very much for coming.